Good morning students. So myself Nivedita Shane. So in the last class we have discussed about ionization enthalpy and the related terms, that is variation of ionization enthalpy, the factors affecting ionization enthalpy and all. So today in this class we are going to discuss about electron gain enthalpy. So same electron gain enthalpy definition discuss martivi. So how it will varies in the periodic table and some important reasons are there, so that we are going to discuss in this class. And one more important term that we are going to discuss in this class is electronegativity. I think you already know about electronegativity, that which group elements are said to be electronegative elements and all. So these are the two things that we are going to discuss in today's class.
So one more concept that is said to be the electron gain enthalpy. So electron gain enthalpy is denoted by the term EGE. Okay, so what do you mean by electron gain enthalpy? How we are going to define this term? It is defined as energy released when an electron is added to an isolated neutral gaseous atom. So ಏನಂತ ಹೇಳಿದ್ವಿ, energy release ಆಗುತ್ತೆ ಯಾವಾಗ, when the energy is released when an electron is added to an isolated neutral gaseous atom. Isolated means separate, so and it should be in the gaseous state. For example, so consider general, that is X ಅಂತ ಹೇಳ್ಬಿಟ್ಟು consider ಮಾಡೋಣ. So it should be in the gaseous state. And energy released, when the energy is released when an electron is added, we know that whenever there is a gain of electron, it will form an anion, that is X minus, right? So whenever the energy is released, energy release adaga, what happens to the enthalpy? Delta H is said to be the negative. And here the unit is also similar to that of the ionization enthalpy, that is kilojoules per mole. So what do you mean by electron gain enthalpy? It is defined as energy released when an electron is added to an isolated neutral gaseous atom, and we know that whenever the electron is added, it will form the respective anion with the negative charge. So this is said to be the electron gain enthalpy. So energy release ಆಗಿರೋದ್ರಿಂದ ನಾವಲ್ಲಿ ಏನಂತ ಹೇಳ್ತೀವಿ, so it is said to be an exothermic reaction. Exo means release, endo means absorb, right? Okay, so we can say that, so here the energy is released during this process, so therefore the value is said to be the negative. But for few elements the electron gain enthalpy is positive. So now ಏನಂತ ಹೇಳ್ತೀವಿ, for few elements the electron gain enthalpy is said to be the negative, right? And for few elements we can say that the electron gain enthalpy is positive. This is for few elements, right? So that means we can say that the electron gain enthalpy, it may be negative or it may be positive. So that we will discuss that how it is for which elements it is negative and for which elements it is positive. We all know that group 17 elements. As I told that electron gain enthalpy value, it may be positive for few elements or it may be negative for the few elements. So we will see for which group elements it is negative and for which group elements it is positive. In the first case, if we consider the group 17 elements, so group 17 elements. So what do you mean by that group 17 elements? Group 17 elements is nothing but the halogens, right? That is fluorine, chlorine, bromine, iodine, and one more, that is astatine. So what is the general electronic configuration? It is NS2 NP5. Outermost shell alli ಎಷ್ಟು electrons ಇದೆ? Outermost shell consists of 7 electrons, right? The outermost shell consists of 7 electrons. To gain the octet electronic configuration, it requires how many electrons? Octet ಆಗಬೇಕು ಅಂದ್ರೆ ಏನು ಆಗಬೇಕು? It gain, so it requires one more electron. For that reason, we can say that for the group 17 elements, the electron gain enthalpy is said to be the negative. Why it is said to be negative? Because to gain the octet electronic configuration, it requires one electron. So one electron add ಮಾಡಿದ ತಕ್ಷಣ what happens to the energy? Energy is released, and that is said to be the electron gain enthalpy. So that is the first case. And in the second case, that is group 18 elements. So that is group 18 elements. So what do you mean by the group 18 elements? They are nothing but the noble gas or inert gas or some rare gas ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಹೇಳ್ತೀವಿ. What is the general electronic configuration? The general electronic configuration is Ns2 Np6. How many electrons are there? 8 electrons are there. So whenever the outermost shell will gain the 8 electrons, it is said to be the stable, or we can also call it as octet electronic configuration. So stable ಅಂತ ಹೇಳ್ಬಿಟ್ಟಾದ್ರೂ ಹೇಳ್ಬೋದು ಅಥವಾ ಅದನ್ನೇನು ಅಂತ ಹೇಳ್ಬೋದು octet electronic configuration ಅಂತ ಹೇಳಾದ್ರೂ ಹೇಳ್ಬೋದು. So therefore we can say that whenever it has gained the octet electronic configuration, whether it has the capacity to gain the electrons, so electron ಬೇಕಾದಕ್ಕೆ no. For that reason what we can say that the electron gain enthalpy for group 18 elements is said to be positive. So what we can say, the electron gain enthalpy for the group 18 elements is said to be the positive. So we can say that it has very less tendency to gain the electrons. So group 18 elements have very less tendency, ಹೇಳ್ಬೋದಾ ಈ ರೀತಿ, they have very less tendency to gain electron because already it is stable. It has gained the octet electronic configuration, or in other words we can say that the group 18 elements have the positive electron gain enthalpies because the energy has to enter into the, so ಏನಂತ ಹೇಳ್ಬೋದು, because the electron has to enter to the next higher principal quantum number. The electron has to enter to the next higher principal quantum number. So what is that principal quantum number? Principal quantum number is nothing but small n. Right? ಇಲ್ಲಿ Ns2 Np6 complete n fill ಆದ ತಕ್ಷಣ if we have, so ಇನ್ನೂ ನಾವು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ಅದಕ್ಕೆ ಹಾಕಬೇಕು ಅನ್ನೋದಿತ್ತು ಅಂತಾದರೆ ಏನಾಗಬೇಕು, it has to enter into the new principal quantum number. So ಅದಕ್ಕೆ ಎನರ್ಜಿ ಏನು ಬೇಕು, so we have to supply the energy. So energy release ಆಗಲ್ಲ. So for that reason what we can say that in the case of group 18 elements, the electron gain enthalpy is said to be the positive. It has very low tendency to gain the electrons because already it has gained the stable octet electronic configuration. Whereas for the group 17 elements, so it requires one electron to gain the stability. So therefore we can say that electron gain enthalpy is said to be negative. The third one, that is said to be the anions have positive electron gain enthalpy. So why the anions have the positive electron gain enthalpy? Anions means which carry the negative charge. So I will give you one example, that is oxygen. So this is in the isolated form, gaseous state. So when an electron is added to a neutral isolated gaseous atom, so in formation agata it will form anion, that is O minus. So energy is released. So energy release ಆಗ್ತಿದೆ ಅಂದ ತಕ್ಷಣ what about the electron gain enthalpy? The electron gain enthalpy is said to be negative, that is minus 141 kilojoules per mole, right? Okay. Now whereas in the case of second electron gain enthalpy, O minus, gaseous state, when an electron is added to an anion, so what happens, one more electron add ಆಯಿತು ಅಂದರೆ ಇಲ್ಲಿ ಏನು ಬರೀತೀರಿ, you are going to write O2 minus. So what about the second electron gain enthalpy here? So it is equal to plus 780 kilojoules per mole. So ಯಾಕೆ change ಆಯಿತು? So why the reason it change? Whereas in the case of the first case ಅಲ್ಲಿ ಏನಿದೆ, negative ಇದೆ, whereas in the second case it is positive. Why it is positive in the second case? This is because when an electron is added to an anion, so what happens, energy is needed to overcome the, so when an electron is added to an anion, so energy is needed to overcome the attraction. Energy is needed to overcome the attraction between anion and electron, between anion and electron. So what do you mean by this? Energy is needed to overcome the attraction between anion and electron. So because ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, so repulsion will takes place. Repulsion ಆಗ್ತಿರ್ಬೇಕಾದ್ರೆ, because negative charge, the electrons are negative charge, so repulsion will takes place. When the repulsion will takes place, what happens? We have to supply the energy. So electrons ತಗೊಳ್ಳಿ ಅಂತ ಹೇಳಿದ ತಕ್ಷಣ ನಾವು ಎನರ್ಜಿನ ಇನ್ನಿಷ್ಟು ಸಪ್ಲೈ ಮಾಡಬೇಕೇ ಹೊತ್ತು the energy will not released. For that reason, so what we can say that here, energy is needed to overcome the attraction between the anion and electron. So energy na ನಾವು ಸಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ ಸಪ್ಲೈ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಸೊ ಅಬ್ಸಾರ್ಬ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಡೆಲ್ಟಾ H value it will become positive. For that reason, we can say that anions have positive electron gain enthalpy. Or one more point we can say that, simple ಆಗಿ ಹೇಳೋದಿತ್ತು ಅಂದ್ರೆ, we know that what happens to the size of anion. So what happens to the size of anion? Anion size ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ when compared to that of the atom? The anion size is more, or we can say that the electron cloud will expand. So electron cloud expand ಆದಾಗ what happens to the force of attraction between the nucleus and the outermost electron? That is, the effective nuclear charge decreases. So when the nucleus ಮತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ಗೆ, ಪ್ರೋಟಾನ್ಸ್ ಮತ್ತು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ಗೆ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಕಡಿಮೆ ಆಗ್ತಿರ್ಬೇಕಾದ್ರೆ, whether it is easy to gain the whether it is easy to add the electron? No. For that reason we have to supply more amount of energy. So energy supply ಮಾಡ್ತಿರೋದ್ರಿಂದ ಡೆಲ್ಟಾ H value ಏನಾಗುತ್ತೆ, it will become positive. For that reason we are going to say that energy is needed to overcome the attraction between the anion and the electron. This next point, this is also very important point, that is the electron gain enthalpy of fluorine and oxygen. Fluorine and oxygen are less than electron gain enthalpy of chlorine and sulfur. So give reason ಕೇಳ್ತಾರೆ. So electron gain enthalpy of fluorine and oxygen are less than electron gain enthalpy of chlorine and sulfur. So what is the reason for this? So I am going to write, so that is group 16 elements and group 17 elements. Okay, group 16 and group 17 elements. Group 16 elements ali first element is oxygen, second one is sulfur. Whereas in the case of the group 17 elements, the first one is said to be the fluorine, the second one is said to be the chlorine. So what they have told, the electron gain enthalpy of fluorine and oxygen andre ಎರಡು ಗ್ರೂಪಿನ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್, that is less than that of sulfur and chlorine. So what is the reason for this? So see here, so if we consider the first group elements, so first element of any group, it is said to be the small size. So this we have already discussed, because as we move down the group, what happens to the atomic size? The atomic size will gradually increases. ಅದರಿಂದ ಗ್ರೂಪ್ 16 ಅಲ್ಲಿ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಆಕ್ಸಿಜನ್ ಅಂದ ತಕ್ಷಣ ಸೈಜ್ ಏನಿರುತ್ತೆ, ವೆರಿ ಸ್ಮಾಲ್. ಗ್ರೂಪ್ 17 ಅಲ್ಲಿ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಅಂದ ತಕ್ಷಣ ಏನಿರುತ್ತೆ, ಇಟ್ ಸೈಜ್ ಇಸ್ ವೆರಿ ಸ್ಮಾಲ್. So what is the general electronic configuration of group 16 element? It is ns2 np4. So group 17 element is ns2 np5. Correct alva? ns2 np5. So here in the both the cases, oxygen and in the fluorine, oxygen atomic number is 8. Okay, I am going to write it here. Oxygen atomic number is 8. That is 1s2, 2s2, 2p4. Whereas in the case of fluorine, it is the atomic number is 9, and we are going to write it as 1s2, 2s2, 2p5. So the electron gain enthalpy of oxygen and fluorine are less. This is because here the added electrons will enter into the same shell. Same shell, and what is the value of n here? N is equals to 2. when the added electrons will enter into the same shell, so what happens between the electrons naduve enagutte, so between the two electrons the repulsion will takes place. So between the two electrons the repulsion will takes place. So for that reason the electron gain enthalpy of oxygen and fluorine is less when compared to that of the sulfur and chlorine. Once again, so here the added electrons will enter into the same shell. So when the added electrons will enter into the same shell, it results in the repulsion of the electrons. So whereas in the case of the sulfur and chlorine, so what happens here, n is equals to 3, correct alva, n is equals to 3. So we can say that whereas in the case of sulfur and in the chlorine, the added electrons will enter into the little bit larger shell, that is nothing but n is equals to 3. So there is a little less repulsion when compared to that of the oxygen and the fluorine. So give reason again, this is very important. The fluorine and oxygen, even though first element ittu kuda, so electron gain enthalpy more irbekiತ್ತು, but even though being a first element, its electron gain enthalpy is very less. So when compared to that of the sulfur and chlorine, this is because of the electron repulsion. The added electrons will enter into the same shell, that is nothing but n is equals to 2. Now we will discuss about variation of electron gain enthalpy in the periodic table. So first we will discuss down the group. So what happens to the electron gain enthalpy down the group? So as we all know that as we move down the group, what happens to the atomic size? So atomic size increase aagta, correct alva? So what happens to the atomic size? The atomic size will gradually increases. Okay, so we can say that first point, atomic size increases. Whenever there is an increase in the atomic size, what about the effective nuclear charge? The force of attraction between the nucleus and the electrons will gradually decreases. So distance ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಯಿತು ಅಂದ ತಕ್ಷಣ force of attraction ಏನಾಗ್ತಾ ಬರುತ್ತೆ, decrease ಆಗ್ತಾ ಬರುತ್ತೆ. We can say that effective nuclear charge will gradually decreases. So what we can say, so whether the attraction of the nucleus for an additional electron will become easy or it is difficult, because effective nuclear charge kadme ide, so it has the not that much tendency to attract the electrons. Anta time alli ನೀವು electron add ಮಾಡಿದಾಗ, so whether it has a tendency to gain that electron, no. For that reason we can say that down the group the electron gain enthalpy will gradually decreases. The electron gain enthalpy will decreases down the group. This is because atomic size increases, effective nuclear charge decreases, and one more point we can say that the attraction by the nucleus, hence the attraction by the nucleus for an additional electron will gradually decreases, right? So because atomic effective nuclear charge kadime ಆಗ್ತಿದ್ದಾಗ, so attraction between the nucleus and one more electron ಏನಾಗುತ್ತೆ, it will gradually decreases. So therefore what we can say, down the group electron gain enthalpy will decreases or it becomes less negative. So electron gain enthalpy decreases, or we can say that it is becoming less negative. So we can say here that is hydrogen, lithium, sodium and potassium. So hydrogen value nodri minus 73 kilojoules per mole, lithium less negative, that is minus 60 kilojoules per mole, sodium minus 53 kilojoules per mole, whereas potassium minus 48 kilojoules per mole. That means it is becoming less negative. So this is down the group. Second point, that is across the period. So what happens to the electron gain enthalpy across the period? So you can see here, that is lithium, oxygen, fluorine. So ಏನಾಗ್ತಿದೆ ನೋಡ್ರಿ, electron gain enthalpy is become more and more negative. So electron gain enthalpy values ಏನಾಗ್ತಿದೆ, it is becoming more and more negative, right? It has become more and more negative. So what is the reason for this? The same thing. So that is as we move across the period, that is from left to right, what happens to the atomic size? So what happens to the atomic size? The atomic size will gradually decreases, right? The atomic size will gradually decreases. So whenever there is a decrease in the atomic size, what happens to the effective nuclear charge? The effective nuclear charge is more, that is the force of attraction between the nucleus and the electron is more. So then what happens to the electron gain enthalpy? So at that time what happens? Atom has a greater tendency to receive an electron. We can say that atom has greater tendency, it has greater tendency to receive an electron, right? So atom has a greater tendency to receive an electron. As we move across the period, the added electrons will enter into the same shell ಆಗೋದ್ರಿಂದ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, atomic size ಕಡಿಮೆ ಆಗುತ್ತೆ. Atomic size ಕಡಿಮೆ ಆಗೋದ್ರಿಂದ the force of attraction between the nucleus and outermost electron is strong, or it is more. So it can hold the electron strongly or firmly. So for that reason we can say that atom has a greater tendency to receive an electron. So ಆಗ ಏನಾಗುತ್ತೆ, force of attraction ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ the atom has a greater tendency to receive an electron. Or we can say that generally what we can say that across the period the electron gain enthalpy increases. So what we can say that across the period the electron gain enthalpy increases. So down the group electron gain enthalpy decreases. Across the period the electron gain enthalpy increases. So this is the three main reasons. Okay. So now the factors which affect the electron gain enthalpy. So factors affecting electron gain enthalpy. So which are the factors that affect the electron gain enthalpy? The first one, that is said to be atomic size. First one, that is said to be atomic size. So what happens, how it will affect the electron gain enthalpy, that we know. Smaller the size of the atom, so electron gain enthalpy will increases. So what we can say, smaller the size, high the electron gain enthalpy. So I am going to write it here. Smaller the size, higher the electron gain enthalpy, Okay, so we all know that small size ಆಯಿತು ಅಂದ ತಕ್ಷಣ what happens to the effective nuclear charge? Effective nuclear charge is more. So that means it can gain or it can hold the electrons. For that reason, so if the size is small, the electron gain enthalpy is more, or vice versa. So bigger the size, smaller is the electron gain enthalpy, and vice versa. ಅದೇ bigger size ಇತ್ತು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, as the atomic size increases, so what happens, the electron gain enthalpy will decreases. So ಈ ರೀತಿ ನೆನ್ಪಿಡ್ಕೊಳ್ಳಿ. This is the first point. Second point, that is said to be the effective nuclear charge. So as I told that whenever the effective nuclear charge increases, electron gain enthalpy also increases, right? Effective nuclear charge ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಯಿತು ಅಂದ ತಕ್ಷಣ the force of attraction between nucleus and electron increase ಆಗ್ತಾ ಹೋದ ತಕ್ಷಣ electron gain enthalpy ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ. That means we can say that it will become negative, right? So at the same time, so whenever the electron gain effective nuclear charge decreases, so what happens to the electron gain enthalpy? It will also decreases. ಇವೆರಡನ್ನು ಒಂದರಲ್ಲೇ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀವಿ ನೋಡಿ. So atomic size increases, right? Whenever the atomic size increases, so what happens? The effective nuclear charge decreases. Effective nuclear charge decreases means electron gain enthalpy will decreases, right? So this is the way that we are going to explain. And one more important term that we have already discussed, that is for the noble gases, that is helium, neon, argon, krypton, xenon. So because it is completely filled, so it has stable octet electronic configuration irodrinda enagutte. So for the group 18 elements, so electron gain enthalpy is said to be positive, right? So remember this point, for group 18 elements we can say that the electron gain enthalpy value is positive, or we can say that the electron gain enthalpy value will decreases. So remember this point, okay? Yes. So now we will discuss one more term which is called as electronegativity. Electronegativity is also denoted by the term that is En. So all the definitions are very important. So that is ionization enthalpy, electron gain enthalpy. Now ಇಲ್ಲಿ ತನಕ ಯಾವ terms ಕಲ್ತಿದ್ದೀವಿ? Ionization enthalpy, electron gain enthalpy. So and now we are discussing about the term electronegativity. All these definitions are very important, right? Now we will come to the point that is said to be the electronegativity. So we already know the term electronegative elements. So which group elements are called as electronegative elements? Group 17 elements are called as more electronegative elements, right? They are called as more electronegative elements. Why they are called so? Because the general electronic configuration is ns2np5. So outermost shell consists of 7 electrons. To gain the octet, it requires 1 electron. That means it has the capacity to attract the 1 electron to gain the stability. That concept is called as electronegativity. So now ಹೇಳ್ತೀವಿ generally. So group 17 elements are called as electronegative elements, right? So ಯಾಕೆ electronegative ಅಂತ ಹೇಳ್ತೀವಿ? Because it has the tendency to attract the electron towards itself. So for that reason that term is said to be the electronegativity. Now we will see the exact definition for this electronegativity. It is defined as the tendency of an atom in a molecule to attract shared pair of electron towards itself. So this is called as electronegativity. So electronegativity andre hege define ಮಾಡ್ತೀವಿ? It is defined as the tendency of an atom in a molecule to attract the shared pair of electron towards itself. Electron ಅನ್ನು ಅದರ ಹತ್ರ share ಎಳ್ಕೊಳ್ಳುವಂತ capacity, attract ಮಾಡ್ಕೊಳ್ಳುವಂತ capacity ನ ಏನಂತ ಹೇಳ್ತೀವಿ? That is called as electronegativity. And the elements which exhibit the electronegativity are called as electronegative elements. ಗೊತ್ತಾಗ್ತಿದ್ಯಾ? To gain the octet electronic configuration, right? To gain the octet electronic configuration, the capacity or the tendency of an atom to attract the shared pair of electron towards itself is called as electronegativity. So like ionization enthalpy, electron gain enthalpy. So the electronegativity is also not a measurable quantity. Like ionization enthalpy and electron gain enthalpy, the electronegativity is not a measurable quantity. So easy agi measure madlikagala. It is not a measurable quantity, right? So for that reason, so two scales were used. One is said to be the Mulliken scale and one more is said to be the Pauling scale. So by using these two scales, we used to calculate the electronegativity of the elements. Nowadays, so which are those two scales? One is said to be the Mulliken scale and one more is said to be the Pauling scale. So here I am going to write, that is Mulliken scale and one more is said to be the Pauling scale. So these two were used. So usually the Pauling scale is widely used. So idu just remember the names, but idra details nimge necessary illa. Just remember this definition. Okay. Now the next important concept, that is said to be the variation of electronegativity in periodic table. ನಮಗೆ electronegativity ಅಂದ್ರೆ ಏನು ಗೊತ್ತಾಯ್ತು. It is nothing but the capacity or the tendency to attract of an atom to attract the electron towards itself, right? That is said to be the electronegativity. How the electronegativity will varies in the periodic table, that means down the group and across the period. So down the group and across the period, what happens to the electronegativity? So that we will discuss. First one, down the group. Down the group. So as we all know that as we move down the group, so what happens to the atomic size? So atomic size increases, right? The atomic size increases. Whenever the atomic size increases, the force of attraction between nucleus and outermost electron, that is nothing but the force of attraction between the nucleus and the outermost electron decreases, right? So iga force of attraction decrease ಆಗ್ತಿದೆ ಅಂದ ತಕ್ಷಣ, so whether it has the capacity to attract the electron towards itself? No, it does not have the capacity to attract the electron towards itself, because force of attraction ಏನಾಗ್ತಿದೆ? Decrease ಆಗ್ತಿದೆ. So therefore we can say that electronegativity decreases down the group. ಗೊತ್ತಾಯ್ತಾ? So atomic size increase ಆಗ್ತಾ ಹೋದ ತಕ್ಷಣ force of attraction between the nucleus, so force of attraction between the nucleus and the outermost electron will decreases. Whether it has the capacity to attract the electron towards itself? No. For that reason we can say that electronegativity will decreases as we move down the group. The next one, that is across the period. Across the period, that is from left to right, across the period. So you tell me what happens to the electronegativity if we move across the period? Yes. So what happens to the atomic size? The atomic size decreases, right? Atomic size decreases, and the force of attraction between nucleus and outermost electron increases, or outermost electron is more. So aga force of attraction ಜಾಸ್ತಿ ಇದ್ದಾಗ, so it has the tendency to attract the electron towards itself. For that reason what we can say that the electronegativity will increases, right? So remember this, down the group electronegativity decreases, across the period electronegativity will increases. So I think you have gone through one common point, so that is for ionization enthalpy agli, electron gain enthalpy agli, athwa electronegativity agli. So as we move down the group enagutte, ionization enthalpy decreases, so electronegativity decreases, and electron gain enthalpy also decreases. The reason is same, the atomic size increases, the force of attraction between the nucleus and outermost electron decreases. So you ಮೂರಕ್ಕೂ ನಾವು ವೇರಿಯೇಷನ್ ಆಫ್ ಹೇಳಬೇಕಾದ್ರೆ ಕಾಮನ್ ಪಾಯಿಂಟ್ಸ್ ಇದೆ, ರೈಟ್? ಸೊ ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್ಗೂ ಸೇಮ್ ಹೀಗೇನೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀವಿ ನಾವೆಲ್ಲ ಟರ್ಮ್ಸ್ ಕೂಡ, ದಟ್ ಈಸ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಆಗಿರ್ಬೋದು, ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಎಂಥಾಲ್ಪಿ ಆಗಿರ್ಬೋದು, ಅಥವಾ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಆಗಿರ್ಬೋದು. ಸೊ ವಿ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ವಿತ್ ದ ಅಟಾಮಿಕ್ ಸೈಜ್ ಆ್ಯಂಡ್ ದ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್. One more important point under electronegativity, so that is electronegativity now we are going to write it, denote it with the term of En. Electronegativity is inversely related to metallic character, right? It is inversely related to metallic character. Okay. So here, what do you mean by that inversely related to metallic character? So ನಾನು ಈ term ಬರ್ದೆ electronegativity is inversely related to metallic character. I think you people all know that. If I write like this, okay, if I write like this, so P is pressure, V is volume. So what does this indicate? So this indicates that you are going to say that pressure is directly proportional to volume, right? So P is directly proportional to volume. So if pressure increases, volume increases. So ಆ ರೀತಿ ಹೇಳ್ತೀವಿ. So ಅದೇ ರೀತಿ if I write like this, so then what does it indicate? It is inversely proportional to volume. So this is just to show you directly and inversely related. So what does this says that, so if the volume increases, pressure decreases because they are inversely related to each other. It is related and already this is directly proportional to each other. Okay. So now in explain ಮಾಡಿದೀವಿ electronegativity is inversely related to metallic character. So I can write like this, electronegativity is inversely related to metallic character. Metallic character. That means, so if electronegativity increases, electronegativity ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತಿದೆ ಅಂದ್ರೆ metallic character will decreases, right? Because they are inversely proportional to each other. ಒಂದು ಜಾಸ್ತಿ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಇನ್ನೊಂದು ಏನಾಗುತ್ತೆ, ಕಡಿಮೆ ಆಗುತ್ತೆ. So at the same time, if electronegativity decreases, then metallic character increases, right? So ಅದೇ ರೀತಿ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ, electronegativity decrease ಆದಾಗ ಏನಾಗುತ್ತೆ, metallic character increases. So this is said to be the inversely related to each other, right? Now I will explain you. So how this is related to the metallic character, inversely related to the metallic character. We know that group 1 elements. So which are the group 1 elements? So that is said to be hydrogen, lithium, sodium, potassium, rubidium, and one more that is said to be the cesium. So here we all know that variation of electronegativity in the periodic table. ನಮಗೆ ಗೊತ್ತಿದೆ. So as we move down the group, what happens to the electronegativity character? The electronegativity will gradually decreases. ಹಾಗಾದ್ರೆ electronegativity decrease ಆಗ್ತಿದೆ ಅಂದ್ರೆ what happens to the metallic character? Metallic character will gradually increases. So we all know that the group 1 elements are called as electropositive elements. So the name and ಹೇಳ್ತೀವಿ, they are called as electropositive elements. Why they are called so? Why they are called as electropositive elements? Because they have a tendency to lose the outermost electron. Outermost electron easy ಆಗಿ remove ಮಾಡೋದ್ರಿಂದ ಅದನ್ನ ಏನಂತ ಹೇಳ್ತೀವಿ, electropositive character. Whether it has a tendency to gain the electrons? No. For that reason, electronegativity decreases, metallic character increases. So this is inversely related to each other. Now this is down the group I2. If we see across the period, that is, I am going to write it here. We know that boron, carbon, nitrogen, oxygen, halogen, that is fluorine, and so on. So as we move across the period, what happens to the electronegativity character? So atomic size decreases, the force of attraction increases, therefore electronegativity increases. So electronegativity increase ಆಗ್ತಿದೆ ಅಂದ ತಕ್ಷಣ, if electronegativity increases means metallic character? Yes. So metallic character ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ? Metallic character will decreases. So therefore these are said to be non-metals. ಅದರಿಂದ ಇದನ್ನ ಏನಂತ ಹೇಳ್ತೀವಿ? Non-metals, right? These are said to be non-metals. So I can tell you one more point, that is non-metals, they have a tendency. So these are non-metals. These non-metals have a tendency to attract. They have a tendency to attract the electron towards itself, right? They have a tendency to attract the electron towards itself. So, as I told that electronegativity is inversely related to metallic character. One more point we can also say that electronegativity is directly related to the non-metallic character. So, ಈ ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಾಗ್ತಿದೆ. ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಏನಾಗ್ತಿದೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತಿದೆ. At the same time, if the electronegativity decreases means metallic character increases. One point ಏನಂತ ಹೇಳಿದ್ವಿ, it is inversely related to metallic character ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಹೇಳಿದ್ವಿ. So one more point what we can say is that is electronegativity is, so this is metallic character. So electronegativity is directly related to non-metallic property, right? It is directly related to non-metallic property or non-metallic character of the elements, non-metallic property of elements. So idunu kuda helidvi. So if the electronegativity increases means, so non-metallic character increases because they are directly related to each other. Don't get confused. So it is inversely related to metallic character and electronegativity is directly related to non-metallic character or non-metallic property. So remember this, how the electronegativity can be explained to the metallic and the non-metallic characters.